Hi everyone, and welcome to our video on converting angles from degrees to radians and also well, let's just do degrees to radians for now. We'll see how that goes. Okay, so to convert one from the other, so it goes back to right here. So we had our problems. Let's draw our axes with this circle on it again. Okay, so we've got a circle, and in degrees going around, we have 0, 90, 180, 270, and then 360 degrees. Well, there's the unit circle that is a big part of trigonometry. Let's add that note right there. A unit circle, I can't spell. Let me try that again. So the unit circle means that we have a radius of 1. And if we go around a circle, that would be a circumference. So the circumference is 2 pi r. And so if we substitute 1 in for that r, then we would say we have the circumference is 2 pi. Okay, so that means going back to our unit circle, or going to our sketch with the degree measures. So if I go all the way around once, we could say, oh, well, that matches a circumference of 2 pi. Okay, so what we're marking now, so in that red, we're just stating, well, 360 degrees as an angle in degree measures, degrees, matches or is matched up to our 2 pi, and that's what we would say is in radians. So radians comes from radius. So the radius of 1 gets plugged in, and we get this right here. So, and we can find other parts about this. Let's get one other side note that I'm going to mark in blue. Well, if I go halfway around, again, that matches up to 180 degrees as an angle measure in degrees. But if I go halfway around a circle and I'm looking at it using the perimeter or circumference, halfway around matches up with pi. Okay, because halfway around, so I know the full length around is 2 pi, halfway must be just pi. And so then we say, well, 180 degrees is equivalent to, so let's take this one instead. So I'm going to box that, and we're going to put a star right here. We're going to say 180 degrees is equivalent to pi radians. Now, we usually don't show radians. So radians we abbreviate as rad, but even then we usually don't even show it because we know if it's blank, it's going to be in radians. Okay, but anyway, so 180 degrees does equal pi radians. Let's just write it right below. 180 degrees equals pi when we're measuring angles. Okay, so we have that, which means we can set up a proportion. So this is where this formula comes from. So it's just stating whatever degree measure I have over 180 degrees must equal whatever radian measure I have over pi. All right, so let's convert these. So convert each angle in radians to degrees, or in degrees to radians, and then we'll express our answer in multiples of pi, and then we'll also round. Maybe we won't round. We'll leave it in terms of pi. Let me move that over. Okay, so let's get this moved. Okay, so this is in degrees. So whenever they have the little degree symbol, so this is telling us we're in degrees. We're in degrees. So notice the question below, this would be in radians because there's no degree symbol. Okay, anyway, so all we have to do is use our setup. So we have some degree measure over 180 degrees should equal some radian measure over pi. Now they're telling us we have 210 degrees. So we're just subbing that in. So 210 degrees over 180 degrees equals some radian measure. Now I'm going to use the generic symbol for an angle. I'm going to do theta, like they said in first video of this section right here. So positive, so they use theta, and then over pi. Okay, so there's our setup. It's just plug away, and then it looks like I can simplify this left fraction. So notice the zeros can cancel out. 21 and 18 are each divisible by 3. Okay, so if we divide each of those by 3, we get 7 over 6. Okay, so we'd have 7 over 6 equals theta over pi. And then I just want theta by itself. So the quick way to do that is to just multiply both sides by pi. Okay, so that way those cancel and I'm left with this theta. So I'm going to rewrite it. I'm going to say this theta is 7 pi over 6 in radians. Again, we don't need to mark radians. We'll just say 7 pi over 6. Okay, so if we're sketching those, so this is why they like drawing that little circle like on the previous problems up above. Let's do it without the circle yet. Let's show the 210 degrees. Okay, so I know again my initial side is on the positive x-axis. 210 degrees, well here's 0, here's 90, here's 180, here's 270, here's 360 all the way around. 210 is just a little past 180, so it'd be something like this. Okay, so that right there is the 210 degrees. 210. Okay, but if we put the little circle there, so this is called the unit circle that we're putting on. Okay, so there's my unit circle that has radius of 1. What they would say is that this length around the unit circle, right here, that same length out, or the same angle that's marked in blue, but now it's in radians. This in red is the angle 7 pi sixth. So it's just saying that far around the unit circle gives us that same angle and we make the same rays. Okay, so we get the same picture, just done in a different way. Okay, so it's just showing degrees versus radians. All right, and then we can plug that into the calculator if we wanted a decimal approximation. I don't think I can pull one up right now, so let's talk about the changing of that in the next video. The 20, but that's the main thing, that boxed answer. Okay, so the negative 25 degrees. So we still want to just mark it, or we will mark it. I still just want to use the conversion equation. Let's put that over here. Degrees over 180 equals a radian measure over pi. Okay, so that's the same. It's always the same thing. And then we say, oh, we have negative 25 degrees over 180 degrees must equal whatever the radian measure is. I'm going to do theta over pi. All right, and so just like before, usually this fraction on the left simplifies. If it doesn't simplify, I mean, that's okay, but on this problem it does. Okay, so the negative 25, these are each divisible by 5. So we would have negative 5. So if we divide each of these by 5, and 180 divided by 5 is 36. And then the degrees actually just cancel out. So it's degrees in the numerator, degrees in the denominator. So those degree symbols are gone. Okay, so I forgot to mention that on that last problem. So the degrees cancel out also. And then, so we just have negative 5 over 36. And then equal to theta over pi. Well, again, just like last time, now that the fraction on the left's fully reduced, we just need to multiply the pi on both sides. So if we multiply both sides by pi, those pi's cancel, and we're left with negative 5 pi over 36. Okay, so that is the angle measurement in radians. All right, and again, just to sketch it, there's our axis. This time, let me go ahead and put the circle there. Let's sketch our angle in blue in degrees. So the negative 25, okay, so here's 0 degrees. Negative means to go clockwise. So that would make that negative 90 degrees down below. So negative 25 degrees is pretty close to 0. So I'm going to say something like that. Okay, so there's our angle, negative 25 degrees. Let me mark it like so. There we are. And then our angle in the radians negative 5 pi 36, well, that would be the same. It's just done a different way. It's just kind of following the circle like that. But we still get the same, let's even highlight it. So the same thing, it's that same angle, just like that. Okay, so that's how we can convert these. Okay, so I'm going to save the calculator for the next video. So, I mean, we could just plug it in, or if you even need it. Okay, so, but just to be safe, what I've got is the important stuff. Okay, except I just can't pull up a calculator right now. Okay, anyway, that's it. Okay, so thanks for watching. If you have questions, please let me know.